Day 837 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3471. Find the largest almost missing integer. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and an integer k. An integer x is almost missing from nums if x appears in exactly one subarray of size k within nums. Return the largest almost missing integer from nums. If no such integer exists, return -1. A subarray is a contiguous sequence of elements within an array. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 3, 9, 2, 1, 7, k equals 3, the output is 7. Explanation says 1 appears in two subarrays of size 3. So first, all of the subarrays need to be size 3 because k equals 3. K equals 3. The first subarray is this right here. Boom, 9 2 1. Sorry, y'all, 9 2 1, and then the second subarray is this right here, 2 1 7. Boom. Then it says 2 appears in 3 subarrays. So then 2 appears right here. It appears right here, and it appears right here. They all have a length of 3. Then 3 appears in one subarray right here, because remember they have to be size 3, so any other subarray of size 3 would not contain 3 since 3 is the first element. Boom, same with 7, except 7 is the last element, so it appears in one subarray. Boom. And then finally 9 appears in 2 subarrays right here and right here. Boom, y'all. And then it says we return 7 since it is the largest integer that appears in exactly one subarray. So it only needs to appear in one subarray, or exactly one, sorry. And so this 7 is the largest one that appears in exactly one. There's only 2 integers that appear in exactly one subarray. That's this 3 and that's this 7, right? And since 7 is larger than 3, boom. And then since, once again, you might say 9 is larger than 7, but that appears in 2 subarrays, right? And 2 is not exactly 1. So the answer is 7. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input nums equals an array of integers 3, 9, 7, 2, 1, 7. This time k equals 4. So the subarrays will be of length 4 and the output is 3. So boom. Let's go through it. It says 1 appears in 2 subarrays of size 4. So we have this right here is one subarray, and then this right here is the second subarray. Then boom, 2 appears in 3 subarrays. So we have right here, then we have right here, and then we have right here. Boom. Then 3 appears in one subarray. That's just this one right here. Boom. Then 7 appears in 3 subarrays. So we have boom, boom. Sorry, it should be 4. Yeah, hold on. 4. Boom, boom. Then 9 appears in 2 subarrays. 4. Boom, boom. So in this case, there's only one integer that appears in exactly one subarray, and that is 3. So we return 3. And as you can see, it's if it starts at the beginning and then there's no other 3s in the rest of the array, then that will be one way to do it. And another way to do it would be like up here if it's at the end of the array and it's not in any other elements in the array. But let's go ahead and take a look at example 3. So in example 3, our input nums equals an array of integers 0, 0. K equals 1. The output is -1. It says there is no integer that appears in one subarray, in only one subarray of size 1. So in this case, this would be a subarray. This would be a subarray of size 1. They both are 0, so there's no integer that appears in only one subarray. So the output is -1 because it says right here, if no such integer exists, return -1, y'all. So boom. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, if k is equal to the length of the array, the only possible subarray is the entire array. In this case, every number appears exactly once in that subarray, so the answer is simply the largest element. So we're going to say, if k equals nums.count, we're going to open up the brackets and we're going to return nums.max and put the parentheses and put an exclamation point at the end. Now we need a dictionary that will store the frequency of every number in the array. So we come underneath this, declare a variable called dict, say colon, square bracket int, colon, int, come outside of that. We're going to initialize it with a blank dictionary like so. Boom. Now we're going to count the number of occurrences of each number. So we're going to say for num in nums. We're going to open up the brackets and we're going to say dict square bracket num, comma default colon 0. Come outside of that plus equals 1. Now if k equals 1, every individual element from its own subarray, a number can be valid only if it appears exactly once in the original subarray. So we come underneath this and we say if k equals 1, we can open up the brackets and we're going to store the largest valid integer found so far by declaring a variable called max underscore, set that equal to -1. Boom. Now we're going to examine every unique number and its frequency. So we're going to say for, open up the parentheses, key, comma, val, come outside of that, and dict. We're going to open up the brackets, and if the number appears exactly once, we're going to update the answer if it is larger. So we'll say if val equals 1 and 2 and signs, key is greater than max underscore, then we'll open up the brackets and we'll say max underscore equals key. Boom. Then we're going to come underneath this and we are going to say, well, hold on. We'll come underneath this and we are going to say return max underscore. Boom. And at this point, 1 should be less than k and k should be less than nums.count. In this situation, only the first or last element of the array can possibly be the answer. So if the first element appears only once, it is a candidate. Otherwise, use -1. Likewise, for the last element, return the largest of the two candidates. So we'll come right here underneath this and we'll say return max, open up the parentheses, dict square bracket nums, square bracket 0, will come outside of that, exclamation point, equals 1, question mark, nums square bracket 0, come outside of that, colon, come outside of that, -1, comma, dict square bracket nums dot count, sorry y'all, nums dot count, come outside of that, -1, come outside of that, negative equals 1, question mark, nums square bracket nums dot count, -1, come outside of that, colon, -1, y'all. Boom, that should be all she wrote. Let's give it a run, make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Let's see, let's see. Let's see, and look at that, y'all. 0 milliseconds. Is it still going? I guess not. 0 milliseconds beats dash percent of users. Not sure what that dash means, but we'll be all right, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.